And this is the second challenge in the buffer overflow series, named dead. So as always, we're going to read the prompt first. Dead. I don't want to fix my buffer. Try to overwrite my buffer with the value of hex dead beef. Hint. Ittiness is the tricky part here. Hint. GDB is amazing for debugging. Try to use it. Hint. Use this to print out data. I'm definitely going to copy this. So the first thing that's said here, the ittiness thing really is the hardest part about this. With different architectures, there is a difference in how memory is represented. You can either have memory go right to left or left to right. This is similar how some languages read in different directions. With little endian, with strings, the most significant byte is actually the rightmost byte, which is unintuitive and not what you'd expect. And this will come up later once we're going through this. But if we look up little endian, this picture comes up. I think it's really helpful to where the most significant bit is going to be this D, while the least significant is going to be the 0A right here. Cool. So if we go to our terminal and we go to the challenge, we're going to write up to the source code. Now the structure is exactly the same as before, where before we just had to overwrite it, we need to now set it with a special value. We still have the 32 bytes and the special int down there. So if we go to the bottom, it's exactly the same up until this if statement. Before, we just had to make sure the value was not 11223344. Now, we have to especially set the value to be dead beef. That's the major difference with this challenge compared to the other one. If you can set this value to dead beef, then you win. Cool. So, damn it, I had to go back and copy that. Cool, got a copy. So there's two things we need to worry about here. There are the actual bytes we need to overwrite our integer with, and then the amount of bytes that we need to buffer before that. As we learned before, the amount of bytes is going to be 32. This is because the string size is 32, and directly after that is the integer that we want to corrupt. Now, the obvious thing to do here would be this. This looks really nice. We are writing the values as you'd expect. And even if you use XXD, this looks really nice, where we can actually read dead beef. I wonder if the XXD has any settings that would be useful for us. Help. Okay. So if you really want XSD to help you, then this is what you want. So E is going to set the ittiness to little endian, which is the architecture of x86. So when the string is being read, it will actually be read this way, which seems weird, but that's just how the architecture works. So if you want to fix this, then we need to reverse how this is being written. We want DE to be at the front, which means we actually want DE in the back. We want EF front. We want the AD set right there. And then we want AD to be BE. So now if we look at this, we can actually see that we actually have gone the proper direction now, which is awesome. So now we have the amount of bytes that we need to go forward, and we have the ittiness correctly. If we run this challenge, we go past that point on the buffer, and it now prints out the flag. So cool, we've now solved this challenge. We've learned about ittiness, and we're going to be using this concept of ittiness going forward. This is actually one of the harder challenges, I feel, of the buffer overflow series, just because understanding how all of that works is and ittiness is complicated. So thanks for joining. See you in the next challenge.